Hi everyone, this is Janine Ko, aka Janine the Tutor. As you all know, now is a very difficult time for each one of us, whether you're in middle school, high school, or university. Many students and families are deeply affected by the recent school closure. And as a part of One Class, we are very fortunate that we are able to adapt to the situation quickly. And because we want to help students stay on top of their studies, that's why we're running daily and free classes for math and chemistry from grades 11 to first year college and university. In addition, we are also offering and giving away 100,000 hours of free private tutoring. So if you're interested, make sure to scroll down below and book your time slot. So for today's class, I will be going over advanced functions or pre-calculus. And we're studying this course collectively because I just think that the best way to learn advanced functions or pre-calculus is to really combine all of your types of functions and be able to evaluate them. Can I get a guess if you can see my screen? And if you can hear me coming through as well? Okay, so let's begin. So the first question we need to figure out whether the function is even, odd, or neither, right? So just as a recap, first of all, how do you know if a function is even versus odd, right? So if a function is even, that means algebraically, you're going to have to plug in f of negative x. So if it's even, if you plug in f of negative x, you need to have f of x. So that's when it's even. And if it's odd, you need to plug in f of negative x as well. But instead of having f of x, you need to have negative f of x. Does that make sense? And the reason for that is because if you're looking at an even function, so say for example, let's start with the basic. We have y is equal to x squared, which is a parabola. We know that this is an even function. So you're going to have this graph right here. So this is y is equal to x squared. And if you think about the symmetry, there we go. So this is an even function. So if you think about the symmetry, that means your function remains unchanged if it is reflected on the y-axis, right? So if you think about this y-axis as sort of like a mirror, so when you flip this part, right, it becomes the exact same reflection, right? So it's symmetry around the y-axis. But for an odd function, let's say you're looking at y is equal to x cubed, which is a cubic function. Okay. So your symmetry is actually 180 degrees, right, over here. And you have a point symmetry, to be specific, right here. So when you kind of rotate this, right, 180 degrees, so you're looking at from here, rotate that until here, right, 180 degrees, you're going to see that your function remains unchanged. So that's the difference between even and odd functions. And that's why you have this positive symbol right here versus the negative sign right here. Okay, so hopefully that was clear. But for this three questions, A, B, C, all you have to do is really evaluate whether you're going to have f of x as a result, which is the exact same thing as your function, versus if you can take out the negative sign and then you're going to have your function, f of x. Okay, and if it's neither, that means it's not going to be any of the two, right? So let's start off by plugging in f of negative x right here. Okay, so we do have 1 over negative x, and then you need to cube this, right? Plus 1. So if you think about cubing negative 1, right? Because this is a negative 1 coefficient, we can actually say that this is going to be 1 over negative 1 cubed. So we're taking out that cube, and then we're left with x, right? plus 1. Does that make sense? So this should still be cube, right? Because we're still copying that cube because it's raised to 3, but then we're taking out the negative 1, and as a result, we know that any negative number raised to an odd exponent is always going to be negative, right?